All right, so we're going to start chapter 7 today, and the first thing we're going to look at is finding the area between two curves. And visually what's going on is we're going to take two equations, and you can see these, they're not very dark. Let me darken what colors you're seeing here. You've got one picture down here that's going something like this, and then we've got another curve that looks something like this. And our goal in this section is to be able to find the area between them. It's obviously an unusual space. We're not going to be able to use stuff from geometry. There's no circles or squares we can sort of shape in this. And also, it's not exactly the same as finding area under curves because we want the area between the curves, but it is related. So we're wanting to find the area between here, and we want to go from A to B, and it doesn't even matter so much if the A and B happens to be the points where they intersect, which it will be sometimes, or it could be some other random value. So, for instance, we could have, let's go that one, this value for A. So that A is here, and we want to go to over here, wherever this ends up being, and this value for B, and we want to find sort of this trapped area right here. Okay, so our method will allow us to do either that, or allow us to actually find these locations first and then find the trapped area. Yes, Cameron? Do we what? We will in 7-2. Yes, we're not there yet. But let me show you how we go about finding this area. So you do know from the other components you've seen in calculus how to take where my red curve is up here and find the area all the way down to the x-axis, right? That's an antiderivative, yeah? That's what antiderivatives do. They find these definite integrals, ones with the numbers at the beginning and the end. They find the area all the way down to the x-axis. And we do that by finding an antiderivative. And I need to label my curve so that this will work. Let's call the top curve F and the bottom curve G, since that's how I described it kind of above, okay? Then we could actually find the area from the top curve in the red all the way down to the x-axis by finding the antiderivative. And if we're wanting to go from A to B, well, we find the antiderivative from A to B. Well, so what we could do visually in this space I've got here, let's just go the A to B here, is I could find this whole area right here on the red, right? And then I could actually just subtract off this area right here. Are you following? But I have a way of finding this area right here. How would I find this area right here? Right. This is just the area underneath the curve of g of x, right? The blue curve down, that was g of x, again from A to B. But one of the properties of logs that you guys learned when you did Calc 1, not properties of logs, properties of antiderivatives or of integrals, right, of these symbols, is that if you've got these separated, they've got the same limits of integration, you can combine them all together so that it instead looks like this. You've got your integral from A to B of f of x minus g of x. And then you take the antiderivative of that subtraction or that difference. Okay, so everybody with me? You visually got the idea of what's going on here. Because in this section you are going to be drawing some pictures, graphs, okay? So grab your calculator out because we're going to start by graphing on these, okay? We're going to sketch the graph corresponding to the following integral and shade the indicated area. So if you take your calculator, the first thing you have to understand is you're not going to put all of this into y1. Okay? Come back over here with me for a moment. Notice what we did. This piece right here came from two different spots, right? The first component was f of x. The second component was g of x. So when we're looking at this particular problem, that's what we have here as well. This is my function f of x. So this would go into y1 in your calculator. And this, not with the minus, okay, the minus is part of what's going on here. This piece right here is g of x. So you're going to take your calculator, and in y1, you're going to put 2 minus x squared. And in y2, you're going to put x squared. Now after you do that, you can either do just a standard zoom window, that would be okay, Or you can use the fact that they tell you they want your x values to go from -1 to 1. Yeah? So you could make your window go from x equals -1 to x equals +1. And then you could tell it zoom 0, which automatically picks a good y window for the x values chosen. Okay, so is everybody getting that equation's graph yet? All you're asked to do in this problem is graph. In fact, you don't even have to find anything. You just have to find the graph. What are these equations both pictures of? What's this image called? They're parabolas, aren't they? Now, if you put them in the right order, the first parabola, 2 minus x squared, should be upside down. Was it? Was it upside down? And not only that, oops, it was upside down looking something like that. Does that look reasonable? Okay, good. Now the other equation, we'll do it in a different color. So my other equation, g of x, was a regular old parabola. It's just the standard x squared parabola, so it looks something like this. And I'm going to label them. I can identify which one's which. Usually I just call the first one f and the second one g. So it says, sketch the graph corresponding to the following integral and shade the indicated area. Well, we would want to make sure, but if you do make sure by plugging in -1, what is 2 minus -1 squared? In other words, if you plug it into f of x, what do you get? 1. And then what is -1 squared if you plug it into g of x? 1. So at -1, that is x equals -1, both of these have y values of +1. They actually do cross right there at that corner. Okay, so that's part of the directions. You have to decide where that -1 is occurring. Maybe it occurs where they cross and maybe it didn't. So you want to double check to make sure. Let's double check the x equals +1, okay? So if I take 2 minus +1 squared, what do I get? That's also 1. And how about +1? Let's do this. Squared for g of x. That looks like a w. It should look like 1. That's better. What's +1 squared? 1. So again, they're the same y value. So this is the other crossing point right here. So if you're told, as these directions told you, that you're supposed to be shading in between them, then you're going to shade, whoops, between those curves. Sound good? All right. Now the next one's going to take that same idea, but it's going to do one more step beyond it. What does it ask you to find beyond what we just did? Find the area, right? We didn't actually find the area on the last one, did we? No, we didn't do any calculus. All you did was actually some algebra, right? Or not even maybe that, but the graphing for algebra. So taking a look at this one, what else do you see that's different about this one? Yeah, it says f of y, doesn't it? That seems sort of strange. But you have to actually treat it like what it says, which means this is a function in terms of y. Now, the first one's probably just fine. You probably recognize or may remember what that one actually looks like. Do you remember what that looks like? It does, almost. We're going to use purple for this one, okay? What would y equals x squared look like? It's a parabola opening up, right? So x equals y squared is also a parabola on its side. So the graph looks something like this. Okay, so this is f of y. Now the other one's a little bit trickier to draw if you're flat out just going to try and draw it. So what I'm going to do is I'm going to take this equation and I'm going to actually find out what this equation would look like if I solved it for y, okay? So this is x equals y plus 2. If I solve this for y, what do I get?
X minus, or y equals x minus 2.
Right? I subtract the 2 to the other side. This is y equals x minus 2. So I can take this graph and I can actually find out what that would look like. And not exactly, but more or less, we're going to have a line that's going to cross the axis down here at 2. So it's going to look something like this. Right? Down here at negative 2, I cross my x or my y-axis down here, right? My y-intercept. And I've got a slope of 1, so I go up 1 and over 1 and so forth. But this one actually gave us directions that the last one didn't. So let me label this before I go on. So this is g of y. This one said, sketch the region and find the bounded area. So I actually want to figure out what those two dots really are. It didn't give me those values like the last problem did. And then I'm going to find, my shading's not perfect, but I'm going to find the area inside of here that I've just shaded. Okay? So, how in the world do I find out the locations where two graphs intersect? Set them equal to each other. Okay? And this is really important because it's fine if you could graph this in your calculator, but you're not going to be able to graph this directly into your calculator because these are functions in terms of y, and your calculator doesn't do that, does it? It does functions in terms of x, and that's a problem for what's going on. So you can't just use your calculator and go with this sort of like the intersect feature in your calculator would, because you don't have that option. So what we're going to do is we're going to set our first function, which was y squared. Here, let me do it this way. My first function, f of y, and it's supposed to equal my second function, g of y. And then literally, my g of y is x plus 2, and my f of y is y squared. Oh, I didn't write x plus 2. I meant to write y plus 2. I'm sorry. Let me get that fixed. There we go, y plus 2. And I need to find out where these two intersect. So how am I going to solve an equation like this? This is going way back in your algebra.
Y plus 2 to the other side.
Okay, so my goal is what, Cameron? So you're wanting me to factor. My goal is to get it all on the same side and to factor it. And the reason that's my goal is because it has a power of 2, right? It's quadratic. That's how we deal with quadratic equations. So I'm going to end up with y squared minus y minus 2 equals 0. And then, just like Cameron said, we are going to factor this. So how will y squared minus y minus 2 factor? I know this is going back forever. Good. Y plus 1 and y minus 2. Then what? Right, so we set each of those two equal to 0, right? Let me move this over here just a little bit. So I've got y minus 1 equals 0, which would mean, plus 1 equals 0, which means y equals negative 1. And I'm going to pause on that for just a moment. And I've also got y minus 2 equals 0, which means y equals 2. Those are the y values. That's actually enough for what I needed. If you want to know the x coordinates to make sure visually that you found the right thing, it's not a bad idea. You could actually plug them into the equations to find out. So if I put negative 1 in for y squared in the first equation, what is negative 1 squared? 1. So this actually ends up being the ordered pair x equals 1, y equals negative 1. And if I put y equals 2 in for the y and y squared, what would I get for x? Four, yes, right? Because 2 squared is 4. So this is the ordered pair 4, 2. Again, that's a visual reference to make sure that this makes sense. Does this point look realistically like the point x equals 1, y equals negative 1? That seems reasonable, right? Does the other point look reasonably like the point x equals 4, y equals 2? That seems reasonable as well. Okay, so that confirms to us that we do have the right values. The reason I say we only need the y values is because this function is in terms of y. Okay? Now think for a moment what you normally do in terms of x. We did the picture just a moment ago. When you have a function in terms of x and another function in terms of x, and we subtract the top one minus the bottom one. That's what we said, right? The problem is this is in terms of y. So imagine taking this picture and turning it on its side, right? Turning what's on its side upright. Or turn your head sideways from your angle. You do like this. Okay? Turn your head sideways. What you're asking yourself is, which equation should be subtracted in which way? How should I subtract? Do I subtract f minus g or g minus f? It will. It will be g minus f. And the reason is because visually what we're doing is we're creating sort of this picture, right? The curve that's on the top is the one that's on the right-hand side, rightmost side. And that's the red one, which was g. And the curve that's closer to the x or to the y-axis is actually my f equation. Everybody with me on that? So we actually have g minus f, the way this picture is set up. Okay? You have to be able to look at these pictures and make those determinations, and it's only going to get harder because the next two sections become very challenging at sort of just deciding on that some of the time. So we actually want an equation or an expression, and we want to take the smallest y value where they intersect, which we found just a moment ago was -1, right? The biggest y value is 2. And then over here, I said we wanted to find our g of y minus our f of y. G of y was y plus 2. And then minus f of y, which is y squared. Okay, everybody with me? All right. This is dy. Once I get the integrand set up, once I get this whole setup done, it works just like it were x. That doesn't matter, right? T, x, q, r, I don't care what I'm taking the variable to be. The integration works the same way. So what is the integral of y? The antiderivative of y? Y squared over 2. You guys are looking at me like I'm asking you a question you don't know. Right? Okay. What's the antiderivative of 2? 2y. And then I've got a minus. What's the antiderivative of y squared? Right. Y cubed over 3. And I don't need a plus 3 because I'm going to be evaluating it to a -1, right? Okay, what I want to see is I want to see that you actually are going to write the 2's in everywhere you're supposed to, and you're going to write the -1 in wherever you're supposed to, and then if you want to use your calculator to actually do this subtracting and then adding, that's fine. Okay, but I want to see that you know what this notation means. And the way you're going to show me that is by showing me that you're really going to take 2 squared over 2 plus 2 times 2 minus 2 cubed over 3. And all of that will subtract -1 squared over 2 plus 2 times -1 minus -1 cubed over 3. Okay, so I actually expect to see that step written out. After this, you can use your calculator to actually do that. That's fine. Okay. Now, these numbers aren't horrid or anything, but if you want to use the calculator on some that maybe are, that would be fine. On this one, this first expression inside of the brackets actually ends up being 10/3. The second expression ends up being -7/6. And then if you combine those, of course, that changes to addition, but you end up getting 9/2. Or if you wanted to write 4.5, that would be fine too. Okay, so everybody with me on what I want to see versus what you can do with your technology. Okay, so this is how we do this problem. And we're going to practice one more before we're done with this lesson, okay? It's going to be back in terms of x, so that piece of this is nice. But the piece that maybe is not quite so friendly to you is what?
Trig.
It's trig. And some of you are not fans of trig, I can tell. So I love trig, so I think this is wonderful. There is something else that's nice about this, and that is that you're actually told your limits of integration. Negative pi thirds, that's really friendly. Because you don't have to do the intersection like we just did in the last one with the quadratic formula and all that. So that's rather nice. You can even use your calculator to get the graph for this. That would be okay, right? We did that on the last one as well. So grab your calculator. You're going to take your calculator and you're going to put in 2 sine x into y1 and tangent x into y2, and you're going to graph them. But you only want the graph between negative pi thirds and pi thirds. And everybody's already in radian mode, so don't think that you have that to worry about. Okay? Be very watchful of what graphs and how, so you know where things are going. Did you get a picture there, Emily? So one picture, and this is the picture for sine. Okay, that's not it. Let's try again. The picture for sine, I'll do it again. I'll do the first one in purple. The picture for sine looks something like this. Did yours do that first? It should have. Okay, so your window's not set right. Your window's going from negative 20 to 20, negative 10 to 20. You want to go from negative pi thirds to pi thirds. There's your pi right there. That was awesome. Yeah. Did you get it, Cameron? Did it look right?
I don't have.
You don't have your calculator. Okay, yours is doing the same thing Nidra's was. Make it go from negative pi thirds to pi thirds. Yes, you have to. Hit window. Make the x minimum negative pi thirds and the x maximum pi thirds. You just told it to graph? Is it going to?
Probably.
Maybe.
Oh, no, it's like that. Oh, why?
Not y. No, negative pi thirds to pi thirds. I'm talking about the window. You don't have one with you today? Okay. It should look like this for sine. So this is f of x. Okay. Hit mode. Okay, that's fine. Oh, let's hit zoom 0. You can start to see the curving a little bit, yeah? That'll work.
Oh, okay.
Okay. Did yours work out there? It's about to. Okay. All right, so this is the first one. Okay, hit window. Okay, that looks good. Now hit zoom and put 0. That will change the Y window, the top and the bottom, to be values that'll be good. The tangent curve actually looked like this. Don't you just love the colors that I can use on the iPad? They really make it easier for me to see the picture anyways. I wish your calculators were in color, don't you? It would be nice. All right, so this is actually the picture you want. There's a couple of things that you could notice here. So we're supposed to find these 2 little pieces of area. One thing you could notice on this particular graph, well, the first thing you should notice is that they cross each other. That's an important thing to notice, okay? The other thing to notice, and this is particular to this graph, but we're not going to use this fact because I want you to know what to do if it weren't the case, is that these 2 little pieces of area are equal. And that's because of the symmetric nature of these graphs, okay? They got wonderful symmetries when you're using trig. So if you want to do the trig on this and you want to appreciate that fact, you could only find one of these little, slivers, and you could just double it times 2, and that would be great. Now, what if you have curves that aren't quite nice, so symmetric? Well, then you can't do that. So I want to show you how you do it in general when you don't have that wonderful feature, okay? Everybody with me on that? But if you were doing this problem, I would do the wonderful feature, okay? I just would. All right, so what you have to recognize is 2 things, or what you have to recognize next about these 2 graphs is that because they cross, part of the time the purple graph's on top, and part of the time the red graph's on top, yeah? So you have to do one of 2 things, and I'm going to show you the 2 things that you can do. And then I don't care which one you do, okay? One thing you can do is you can actually be really careful to make sure you see which one's on top of which. So when you're creating your integral, and there's actually going to be 2 integrals here, you can take your integral, and it's going to go from negative pi thirds to 0 because they cross at the origin. This right here is occurring at negative pi thirds because they told you that when they started the problem, right? And this one's occurring at pi thirds, which happens to be where they intersect. And then they cross right here in the middle, sort of like a bow tie looking feature, or maybe a boomerang or something. No, that's not a boomerang. A flying something. Propeller, it looks like a propeller, yeah. So they cross in the middle at actually the origin. So I'm actually going to take the integral from negative pi thirds to 0 because that's one little sliver over here on your picture, right? And on that piece of the graph specifically, the red curve's on top, which is g of x, and then the purple curve, which is f of x, is on bottom. And then I can add this to, and I can go again now from 0 to pi thirds, and my subtraction goes the other direction because the purple curve, f of x, is actually on top of the g of x curve on this one. Okay, so that's one way to handle it. Here's option number 2. Is you do the same thing as far as creating the intervals. This goes negative pi thirds to 0, and I'm going to have 0 to pi thirds. But instead of worrying about which one's on top of which, you just use absolute values. Because no matter how you do the subtraction, you should be getting a positive number when you're done, if you really took the top one minus the bottom one. So you can avoid worrying about which one's on top and bottom if you'd like by using absolute values. And there should be dx's at the end of that second integral, but I'm out of space, so pretend they're there. You just can't see them. So it doesn't matter which one you go with, okay? You're going to get the same answer either way. Which one would you like to use for this particular problem? I'll let y'all pick. The top one. Okay, so Cameron wants us to use the top one. If you don't like the top one, then you can do your own. But I'll do the top one on the screen. So we're going to take the integral. Our integral is g of x first. G of x is tangent x minus 2 sine x. And this goes from negative pi thirds to 0 dx. Again, what I would do on this particular problem, because of the symmetries that are involved, is you could just put a 2 in front of this sucker and you could be done with it. There's only one integral to find, okay? Because each of these pieces of area are equal, right? But again, in general, that's not the case for functions, so we're going to treat it like it's not. We're going to add to this the integral from 0 to pi thirds. And on the right-hand side of the graph, we actually have the function f of x, which is 2 sine x on top. And we have g of x, which is tangent x on bottom. So I need some antiderivatives. What's the antiderivative of tangent? That's the derivative of tangent as secant squared.
It's like the...
Do you guys need to take your gateway again, your basic skills test again?
Hey,
Hey.
this is we haven't took that
Oh, that's
one
true.
yet.
We haven't taken it yet. We're going to do that really soon, though.
Oh, man.
I think it's a couple weeks still. So I think you're right. Yes, Nita, do you know what it is? That is exactly right. The antiderivative of tangent is negative natural log of the absolute value of cosine of
On
x.
one of the assignments,
Mm-hmm.
that was on there, like the derivative of tangent, but then I split it up and I didn't notice that the antiderivative was that. So I was like doing the trig part, how you get to that
Yeah.
antiderivative. And halfway through I realized I could just use the rule.
Okay, so what's the antiderivative of sine x?
Negative cosine.
Mm-hmm. It is negative cosine, and this is already negative, so I'm going to turn it into a positive, okay? All right. All of this gets to be evaluated at 0 and at negative pi thirds. Okay. I have the second half of this thing, and let me go ahead and fill it in while I'm here. So this is 2 sine x. We already did that. That should be negative 2 cosine of x, right? And then the tangent should be minus, and then it'll be that subtraction will turn into a positive because the antiderivative of tangent is negative natural log. So I got 2 negatives of the absolute value of cosine of x. That's an x. I can't draw it. And then I need that pi over 3 and 0 on the edge there, and I'm out of space too. I'm running myself out of space. Okay, because you've got natural logs involved, if you decide to use your calculator to find this, it is not going to give you an exact expression. So we're going to do it by hand, because that's more fun anyway. So the first thing we're supposed to do is put 0 in. So I have, what do I have? I have negative natural log of the cosine of 0 plus 2, what was it? Cosine of 0. Right? Did I get that all right? Okay, then I'm supposed to do this, and I'm supposed to take this, and I'm supposed to subtract the same thing with the negative pi thirds plugged in. So I have negative natural log of, of the cosine of negative pi thirds. And then it was plus 2 cosine of negative pi thirds. All of this is supposed to be added to the other one, the other antiderivative that I had, where we plugged in the pi over 3 and 0. So on this other one, now I have, what was my expression over here? Negative 2 cosine. Pi thirds gets plugged in first. Was it plus natural log? Plus the natural log of the cosine of pi thirds. That is minus the same expression with 0 plugged in. So negative 2 cosine of 0 plus the natural log, oops, this is supposed to be absolute values over here, of the absolute value of cosine of 0. So I think we need to find the cosine value of 3 different things, and then we'll be able to work with the rest of it, right? So first, what is cosine of 0? It is not 0. It's cosine of 0. That is sine. It's 1. So I have negative natural log of 1 plus 2 times 1 minus. Okay, what is the cosine of negative pi thirds? What's your calculator tell you, Dylan? Obviously, we need to have a unit circle quiz. We might.
What did you say?
The cosine of negative pi thirds. No, but you're close.
It's one of those.
It's
1/2, yes. So I've got the negative here, so this is negative natural log of 1/2 plus 2 times 1/2. Okay? Now let me do this piece down here, and I'll do it in purple so I can keep track of what I was doing. Plus. All right, so if the cosine of negative pi thirds is 1/2, it's actually also the case that the cosine of pi thirds is 1/2, because cosine is an even function. So this should be negative 2 times 1/2 plus the natural log of 1/2 minus, and then we already did the cosine of 0. That was 1. So this is negative 2 times 1 plus the natural log of 1. All right, before I go any further, somebody's going to tell me what the natural log of 1 is. It is 0. So this is 0, and this one's 0. Correct? what do I have left? I have 2. I'm going to distribute my negatives. And I have plus the natural log of 1/2. Minus 2 times 1/2 is 1, but it's minus because there's a negative out here, yeah? Plus, then I have negative 2 times 1/2, so there's negative 2. So let's change that to be a negative, or negative 1. And then I have plus the natural log of 1/2. And then I have negative and negative here, so this is positive 2. Did I get them all? Okay, let's collect like terms. Let me do the natural logs first. I have 2 ln 1/2. Then I have 2 minus 1 plus 2 for a grand total of 2. You can leave it like this if you'd like. If you're looking in the back of the book, they might not like the fact that it's a 1/2 in there. I don't know. They might change that to be 2 to the negative 1. And then pull that negative out in front. So it's possible that you might actually see that written as negative 2 ln 2 plus 2. I don't know. We could do that. I don't care if you do that, but you have to be able to look at what they've got and verify that it's what you have. Make sense? All right.